Okay, so in this video, this should be the last video that you have to watch. It is writing and naming acids and bases. Okay, so we're going to be learning what an acid is and what a base is. Now we've already seen bases before, but now you actually get to know that it's a base. So the rules for naming acids is if it ends in IDE, then you're going to change it to have an hydro in front of it, put the element here, and then change the ending to ic and put the word acid because it's an acid. If it ends in the word ate, then you're going to change, you're not going to put the word hydro, you're just going to change that ending to ic and acid. And if it ends in ite, then you're going to put ous at the end of the word and put the word acid. Okay. Now, to know if something is an acid, that's our next part. If a compound begins with hydrogen, with the hydrogen name, it is an acid. So if you see an H in front of it, so an H attached to any element here, then it's going to be an acid. There's only one exception for this, and I'll show you when we get to the examples down here. There's only one exception, but everything else will follow these rules right here because it would be an acid. Okay, so let's do the first one. So the name of the first one, I have H2CO3. I know this is an acid. Why? Because it begins with H. Begins with H, it's an acid, so I'm already going to write the word acid here because I know it's an acid. Acid. Now I need to figure out what this beginning part is. So what is CO3? Now CO3 is more than one element. Hold on. CO3 is more than one element, so we got to look at the back of the periodic table. I look at the back of the blue periodic table. It is a polyatomic ion. Polyatomic ion, CO3. CO3, there it is at the top. CO3, -2 charge. This is called carbonate. So, off to the side, let's write the word carbonate. Now, this word right here ends in the word ate. Carbonate. So let's look at our rules. It's not going to be rule 1, it doesn't end in IDE. It's going to be rule 2, 8. So I need to put the first part, carbon. Then I need to put IC, because that's what it wants there, IC. Acid. We're going to call this carbonic acid, and that is the correct name right there. So H2CO3 is called carbonic acid. Move on to this example. H3N begins with H. Perfect. So this is an acid. Let's figure out what N is. N is just an element. So we look at the front of the periodic table. N is right here, nitrogen. So let's put nitride. Remember, when it's an element, we change that ending to IDE. It is a non-metal. IDE. IDE there. So let's look at our rules. It's going to follow the first rule, IDE. So we're going to put the word hydro first. So hydro. Then some of the elements. So the nitri part. Nitri. Oh, I'm sorry, not the I. TR, then I want IC, acid. Hydronitric acid. That's what H3N is. Let's look at this one. Hydrofluoric acid. So this one I give you the name instead of the formula. So if I give you the name, then I want the formula now. So hydrofluoric acid. Looking at the rules, it follows this first rule. Hydro, ic, acid. So that means it's going to end in IDE somehow. Now, since I know it's an acid, it has to start with H. And fluoric, so that looks like fluorine, so let's put an F here. Now, I don't know if this is correct. It could be, it could be not. It could not be. So we're going to write H, F on the top to the side. Hydrogen has a +1 charge. Fluorine has a -1 charge. What do I do to those charges? Nothing, because they cancel out. +1, -1, so I just put them together, HF. That's the correct formula. Next one. Sulfuric acid. Acid, so it begins with H, with a +1 charge. This one follows rule number 2, ic acid. See that? So it's going to end in the word ate. So instead of sulfuric, it's going to be sul and then fate. Has that ate part. So what is sulfate? That's not an element, remember. Sulfate I find on the back of the periodic table. Right here. Polyatomic ion. SO4, -2. So this would be SO4, -2. Now I have a +1, -2. I'm going to cross those charges. So I'm going to have H with the 2. How many SO4s am I going to have? I'm only going to have 1, so I don't need parentheses. So it's just going to be SO4. And there's my formula. Okay. Let's go to these examples where I'm just naming them. Oops, sorry. I have HI. HI, that's obviously an acid. Well, what is H? I'm sorry, what is I? I is iodine. Iodine, but remember you change the ending to iodide whenever it's an element, when it's a compound and you put it together. So since it's a compound here, it's iodide. IDE, it's going to follow this first rule then. Hydro, iodic, something like that, acid. So, IOD, is there a no? No, I don't think so. Iodic acid. Oh, hydro. I have to put hydro in the front because it's just an element. Hydroiodic acid. This one, HBr. Br is bromide. Bromide. And so that's going to follow the first rule just like this one. So it's going to be hydro bromic acid. H2S. Remember I said there was an exception. Here is it. This is an exception. This is the only exception, I believe. H2S. H2S is the only one that is not called an acid. Okay? The reason why is because it doesn't behave like an acid whenever you put it into water. So, all this one is called is hydrogen sulfide. Okay? That is not an acid. Let's keep going. H2SO4. This is an acid. SO3. That is a polyatomic ion. Ooh. We need the blue sheet for that one. SO3, right there. Sulfite. Sulfite. That's what it's called. Sulfite. So this one's called sulfite. Sulfite. It ends in ITE, so it's going to follow the third rule. OUS acid. So sul FOUS sulfus acid. Or is it sulfurious? Maybe it's sulfurious. UROUS. There's a UR in there. Next one. HMNO4. Let's figure out what MnO4 is. That's a polyatomic ion. MnO4. It's called permanganate. Permanganate. So, let me write it off to the side. Permanganate. It ends in ATE. Is that better? That's a little better. Ends in ATE. So it's going to follow the second rule. So it's going to be permanganic acid. Permanganic acid. Next one. I have C2H3O2 after the H. So that is up here. So that is acetate. So let me write it. Acetate. Acetate ends in ATE, so it's going to follow rule number 2. So this is going to be acetic acid. Okay? So we're just changing that ending, really. All right, so try pausing the video and try doing some of these on your own. I am going to go over all of them in a sec. Okay. All right. HI. We've already done that one up there, but let's just do it again. I. The name of the ion. I is iodide. Iodide. Because it's just an element. And so the way I'm going to name it, and that's going to follow rule number 1. Hydro, put some of it, ic acid. So hydro. I'm sorry, I don't mean to capitalize that. I just keep doing it for some reason. Acid. All right, next one, sulfite. Here I have ITE at the end. So what is sulfite first? Okay, sorry. So sulfite on the back of the periodic table is right here, SO3 -2. So let's write that right here, SO3 -2. I'm going to put hydrogen on this side, H + 1. So to get my formula, what am I going to do? I'm going to cross those charges. Those charges get crossed. So I'm going to have 2 H's and 1 SO3. And there goes my formula. Since it ends in ITE, it's going to follow rule number 3, which is change the ending to OUS acid. This would be a good one to redo. So sulfurous acid. Next one, nitrate, ends in ATE. All right, so nitrate on the back of the polyatomic ion is NO3 -1. Hydrogen is H + 1. What do I do to those charges? Actually, let me just show you. Remember, nitrate, right there. That's where I got that formula from, NO3 -1. The charges cancel out, so we just plug them together. H, NO3. Since it ends in the word 8, it's going to follow rule number 2. Just change the ending to ic acid. So nitric acid. Here, I only want us to look at this one, this first equation there. There's an H there in the beginning, so we know it's a acid. So C2H3O2. What is that called for my anion? C2H3O2, there it is, acetate. So acetate. And they already give me a formula, so I don't need to write it to the side. What's the name of this new compound after I put the H? It ends in ATE, so it follows rule number 2. Acetic acid. Next one. Here I have the word hydroic acid. Looking up here, hydroic acid. So it's going to end in IDE. So this is bromide. Bromide. What is bromide? That is Br -1. H is +1. So we just put those together because it's +1 -1. They cancel out. HBr. Here they give me the list of ion, which is sulfide. That is not a polyatomic ion, that's an element. That is sulfur with a -2 charge. And then we have hydrogen with a +1. Cross those charges and we're going to get H2S. Since it ends in IDE, that follows rule number 1. Hydro. How do you spell it? Sulfuric acid. For some reason they leave the U and the R inside the name. Sulfuric acid. So hydrosulfuric acid. Oh, wait, no, just kidding. That's wrong. Cross this out. Remember, I said this was the one exception. See? Exception. I call that hydrogen sulfide. My bad. Remember, that's the only one that's the exception. H2S. H2S is called hydrogen sulfide. Oops. Next. HNO2. The anion will be this part, NO2. So NO2 is called, let's see, NO2, there it is. NO2, nitrate. Nitrate. NO2 minus 1 charge, hydrogen plus 1. We're going to call it, since it ends in ITE, it's going to follow rule number 3. So it's going to be nitrous acid. Next, chromic acid. So since it ends in IC only, that's going to follow the 8 rule. So that's chromate. Chromate is on the back of the periodic table. Where's chromate? There it is. CrO4 negative 2. O4 negative 2. Hydrogen is a plus 1. Cross those charges, and I will get H2CrO4. Phosphate ends in the word 8. Phosphate is PO4 negative 3, and it's a polyatomic ion. Hydrogen is a plus 1. Cross the charges. H3, PO4. Since it ends in 8, follows rule number 2. Phosphoric acid. Next one, perchloric acid. Now all I'm looking at is the ic acid, so I know that it follows rule number 2. Since I know that it's rule number 2, then I know that it's perchlorate. Perchlorate. Chlorate is a polyatomic ion on the back of your periodic table. It is ClO4, negative 1. Hydrogen is a plus 1. Plus 1 minus 1, they just go together. HClO4. Boom. Cyanide. Cyanide is not an element. You can't find that on the front of the periodic table. It is right there. Cn, negative 1. Hydrogen is plus 1. Charges cancel out. HCN. To write the name of this one, it ends in IDE, so it's going to follow rule number 1. Hydro. Cyan. And then we're going to put ic acid. There we go. And last one, H2Cr2O7. Let's look at the second part, Cr2O7. What is that? That is called dichromate, Cr2O7 with a negative 2 charge. Dichromate. Cr2O7, negative 2 charge. Hydrogen has a plus 1. Cross those charges, and that's how I get this formula. Since it ends on the word 8, we're going to call that, it's going to follow rule number 2, dichromic acid. There we go. Those are our acids. Our bases are much simpler. For naming bases, all you got to do is name the metal. If it is not in group 1A, or 1, 2, aluminum, which has a plus 3 charge, cadmium has a plus 2, zinc has a plus 2, and silver has a plus 1. It does require Roman numerals. That should have been from video 3. If you don't know what Roman numerals are, rewatch that one. To indicate the charge of the metal, then add the name hydroxide. That is the name of the polyatomic ion. Okay, so on the back of your periodic table. So basically, if there's an OH, you see that there's an OH, that polyatomic ion, that's called a base. This is a base. So I have acids, and then I have bases. They are opposites of each other. So this first one, MgOH2. Mg is called magnesium. OH is called hydroxide. And that's the name of that element. Magnesium is a +2 charge. It is in the second group, meaning that we do not need to put Roman numerals. I know that this is a +2 charge. Next one, lithium hydroxide. So lithium, I know the charge of this one. It's in the group 1A, so I know that it's going to be a +1 charge. So lithium hydroxide. NH4, that looks weird. That's because it's a polyatomic ion. NH4 right here. NH4 plus 1, that's called ammonium. And then OH, hydroxide. Cu is copper, but here we go. Copper's right here. That does not follow the rules. It is not in the first row, the second row. It's not aluminum. It's not, doesn't have a charge. It's not zinc. It's not cadmium. It's not silver. So I need to put Roman numerals with this one. Okay. Now to figure out what the charge is, let's look at hydroxide. Hydroxide here has a -1 charge. Since it has a -1 charge, we know that one hydroxide has a -1 charge. But I have two of them. I have two hydroxides. So in total, I have a -2 charge. So one hydroxide's -1, but I have two of them. So in total, I have a -2 charge. Copper, to cancel that out, needs to then be +2. It has to have a +2 charge. So we're going to write copper, Roman numerals, 2 hydroxide. Ag, I know the charge of Ag, it's right here, it's +1. Remember, it's always +1. So that one I don't need Roman numerals. Silver hydroxide. Last one, Fe, iron. Fe is located right here. It's in the middle. It's a transition metal. It doesn't follow the rules where it's in zinc, cadmium, or silver. It's not in any of the groups that have charges, so I need Roman numerals with this one. Now again, like I said, hydroxide is a -1 charge, but I have 3 of them this time. 3. So in total, I have a -3 charge on the right. So iron has to be +3 then. So it'll be iron, Roman numeral 1, 2, 3, hydroxide. There you go.